Good evening, Namaste. This is me, Geometric Engineer Vishnu Atreya. This is my third tutorial video. In first tutorial, I had demonstrated the working interface of ArcCatalog and ArcMap of ArcGis software. In second tutorial, I had demonstrated how to add spatial data and present their qualitative attribute of file in ArcMap. In this tutorial, I will show how to present quantitative attribute in ArcMap. Let's start. Let's start ArcGis. You can go through ArcMap 10.3. I have already opened because it takes time to load. Let's add any map, any shape file, and let's inspect its attribute. There are so many attributes. Among them, we are going to present sum of Magar population of Nepal of each district. As we know, population is quantitative and ratio data. So we go to symbology, not category but quantities. In quantities, there are 4 options to represent the data: graduated color, graduated symbol, proportional symbol, and dot density. Let's go to graduated color. Of what data? Sum of Magar. Here number of class are 5 and data and quantitative data is sum of Magar population, and we are not normalizing it by any things. Normalizing means dividing something. Let's suppose it is if we are calculating population density, then we have to divide it with area of the polygon, each polygon, then it calculates the density of the population. Now we are not doing anything, we are just showing the exact sum of Magar population. That's why we are not normalizing by any field. So let's go to classify. There are so many methods of classification. For example, manual, equal interval, defined interval, quantile, natural breaks, etc. Natural breaks. In manual, we can classify the range of the data according to our own. We can define manually by ourselves. We can put value by ourselves like 8,000, 7,000, 8,000, and this way we can, or we can just dragging this from up to this and this up to this up to this. This way we can classify the range of data manually. Let's see what happens. Okay, if we classify manually, the value also we can put manually over here. Let's see what happens. This is manual classification of attribute data. We can use the cartographic rule to represent to choose the appropriate method of quantitative data in ArcMap. Let's do the classify. In manual, it does not have any class. We can classify manually number of class. It does not have any number of class. In equal interval, if there are 5 classes, the all range is divided into 5 and the interval is equal. We can see this is the histogram of data and we can see the interval is equal if here the number classes is class can be changed. In manual we cannot change the in manual classification we cannot change the number class, only interval can be changed. In equal interval the range is equal. Let's see what happens. Yes, the Magar population 0 to this much is represented by this color and this much to this much represented by this color and so on. Higher the population, higher the saturation of the color. This property, symbology and classify. Let's go to defined interval. In defined interval also we can put the size of interval. Let's say 5000. Then it contains so many 28 classes. Or we can into 3000. So we can classify the data according to the size of the interval, that is defined interval. In quantile each class, in quantile there is no any equal classes. Each class contains equal number of features. Look, the features total number of features of the class are equal. We can classify into how many classes? Many classes, but classification is such that the number of features are equal in each class. Then let's go to classify natural breaks. Natural breaks are classes are based on the natural grouping inherent in the data, that is similar values are in same group. Apply, and we can also classify the data according to geometrical interval and standard deviation. Standard deviation is the number of class that are really nearer to mean, that is variance. If the variation from mean is displayed here. Let's see. But selecting the appropriate classification methods depends upon the cartographic rule. It is better to read ArcMap help and refer any cartographic rule. Let's go to graduated symbol. Graduated symbol, let's see. Yes, there are dots which shows the Magar population. Smaller the dot, smaller the quantity of population, larger the size of dot, larger the population of size. Now let's classify this with not in standard deviation, manual, not manual, let's say to equal interval. Okay, apply. Yes, in graduated symbol the dot value varies from 4 point to 18 point. It is not in scale, but it gives the idea of range of the quantity, but it is not in scale. It have classes. Look, we can see the 4 class. We can divide into 9 class. We can divide into 10 class. That is the point from 4 to 18 classified into 10 size to represent the quantitative attribute of Magar population. Property. Let's go through the proportional symbol. Proportional symbol does not have any class, but its the size of point value varies according to the quantity of the attribute. Yeah. It seems similar to graduated symbol, but it is different. In graduated symbol, the point value, the size of point dot is from 4 to 18. We can edit 30 also, and the small size should be 2 also, 2 to 20. Number of classes are 5. Then this 2 point to 30 points can be divided into 5 times according to the, and within this the quantity is to be demonstrated. But in proportional symbol, the radius or dimension of the dot value increases according to the quantity of Magar population. Let's go to dot density. In dot density, we can show not only one field. Let's other field also. First show only one field, that is sum of Magar population. Here one dot value equals to 900 population, we can change this 1000 population. Apply. Okay. Yes, some districts are disabled because some districts do not have more than 1000 population. No, all population, all pointer maps are showing. Yes, and we can fill this, we can fill color of the background so that it is more. Yes, yes, this one dot means 1000 population average average. We can see the most dense population lies here, and less population we can see the Magar population density of Nepal by dot map. We can add other also, for example Magar and any right Tharu. Let's give another symbol for Tharu. Okay, and this for Tharu, let's give this symbol. Okay, for not only, let's 10. Okay, for Magar, let's give another symbol, this. Okay, apply. Okay, it is became hang because large data. Let's change the color of Magar. Property, some this Magar have red color. Let's design simple and red, and size is 5. Okay, and this is also 5. Okay, let's, this is 10, 1, 2, 3, 10,000. Apply. Okay, so we can see the Magar population and Thar population in each district. 1 dot equals to 10,000. This way we can present the quantitative data. Then there are other methods also we can present. Yes, we know graduated color, graduated symbol, proportional symbol, and dot density. I will say again, graduated color gives color saturation according to the quantity. Graduated symbol gives the class of symbol within a limit of size according to the class of the range of the data, and proportional symbol gives the size of the symbol according to the quantity of the data, and dot density gives one dot proportional value of the quantitative data. One dot equals to 100 unit dot value, like this. And in dot density we can demonstrate two or more attributes and so on. Let's go to chart. In chart we can show pie, bar or stocks. Let's show Magar population and Baramu population and Tharu population. Tharu population. Apply. Okay. Three population shown in only one district. I think its attribute have some problem. It does. Let's check another way. Property, remove all Magar. We are doing Magar population and Newar population. We can design the sign also. We can give the background color from here. We can give color ramp from here. And let's some of Rai also. Apply. Okay. This way we can demonstrate the population of different ethnic group of each polygon by pie chart. Let's label the district name. Yes, we can compare the population of. We can change the color also. Rai and Magar color are seen the same color. It is not better idea. Hence, let's change the color ramp. If you don't like, you can change from here also manually. This is red. Okay. This is blue. Okay. This is green. Okay. Apply. Okay. Yes. Similarly, we can present this data into bar diagram also. Apply. Okay. Zoom to layer. Similarly, we can present this data into sticks also. Zoom to layer. Yes. Property. Now last, multiple attribute. In multiple attribute we can demonstrate two fields, some quantitative and qualitative, and qualitative and qualitative. Here district is District data is nominal data, that is quantitative, not quantitative, qualitative data. We can change the color ramp of district, that is chromochromatic map, that we have already done in previous tutorial. And we can change the symbol size of the what. Let's do sum of Magar population, number of class 5, 10, whatever you like. Okay, apply. Okay, sorry, we did not give add all value here. If we give add all value, then you can say yes, different color for different district and different size for different quantity. Let's choose another color ramp. It does not look nice. I do not like this. I think it would be better. Yes. Now we can see different color for different district, different size, or size according to the quantity of Magar population in each polygon. This way we can show the quantitative data of any spatial data in ArcMap. In summary, for single, to change the color of spatial data of single symbol, we can use feature class. For category, for nominal data, we can use categories. For quantitative data, we can choose quantity. And for two or more quantitative data, we can go through chart. And if quantitative and qualitative data to present both qualitative and quantitative data, we go through multiple attribute. Okay, this much for today. If this video is useful to you, if you think it is useful to you, then you can like and subscribe it. In next video, I will show how to create vector data. This much for today. Thank you for watching. Thank you.